So far, our differentiation videos have used functional notation. In this one, we're going to look at Leibnitz notation. So an alternative notation for the derivative, instead of f-x in functional notation, Leibniz notation is written as the change in y over the change in x, or dy by dx. So for example, f of x equals x cubed differentiated to f-x equals 3x squared in functional notation. If we have y equals x cubed, it's going to differentiate to dy by dx equals 3x squared. So we're going to use Leibniz notation to find the derivative of y equals 4x squared plus the square root of x. So we need to put this in a differentiable format. So y equals 4x squared plus x to the power of a half. And so dy by dx is going to equal 8x plus a half multiplied by x to the negative a half, and then we're going to write that as the derivative of y with respect to x equals 8x plus 1 over 2x to the power of a half, and then we're going to change that into root form, so the derivative of y with respect to x equals 8x plus 1 over 2 root x. So in this example, we want to find the derivative of 3t squared plus 1 over 3t with respect to t. So first of all, we need to put it in a differentiable format by putting the 1 over 3t as a third of t to the minus 1. And now we can differentiate with respect to t. So our derivative is going to become 6t minus a third times t to the power of negative 2. And if we rewrite that as positive indices, we've got 6t minus 1 over 3t squared. Now this example, we want to find the rate of change of 4 root t at t equals 9. So we need to differentiate because it's asking us to find the rate of change. And then we need to evaluate by substituting in t equals 9. So we need to write this in a differentiable format. So we're going to write it as y equals 4 multiplied by t to the power of a half. Then we can differentiate it with respect to t. So the derivative of y with respect to t equals 4 times a half, which is 2, t to the power of negative a half. And we're going to rewrite this with a positive index. So the derivative of y with respect to t equals 2 over t to the power of a half. And then we're going to rewrite that as a root. So it's 2 over the square root of t. And now we need to substitute in our value of t, which is 9. And so the rate of change of 4 root t at t equals 9 is going to be dy by dt equals 2 over the square root of 9, giving us a value for the rate of change of 2/3. In this example, we want to differentiate r equals 8p to the power of a half minus p with respect to p. So in Leibniz notation, we're going to be calculating dr by dp. So we bring down the power and multiply it by 8 to get 4p to the power of negative a half minus 1. And then we're going to write that in a positive index as 4 over p to the power of a half, take away 1. So the derivative of r with respect to p for this function equals 4 over the square root of p, take away 1. Now in this example, we want to find the gradient of the tangent to the curve y equals x plus 3 upon x minus 5 all over x squared at x equals 5. So we need to put this in a differentiable format. So we need to expand the bracket. So we've got x squared minus 5x plus 3x gives us minus 2x, take away 15, and that's all over x squared. And we need to then make it so that the form is x to the power of n by splitting it into separate fractions. So we're going to have 1 minus 2x to the power of negative 1 minus 15 times x to the power of minus 2. So dy by dx, or the derivative of y with respect to x, is going to equal 2x to the power of negative 2 plus 30x to the power of negative 3. And we're going to rewrite that with positive powers. So dy by dx is going to equal 2 over x squared plus 30 over x cubed. Now we need to evaluate that derivative to find the gradient of the tangent of the curve by substituting in x equals 5. So the derivative of y with respect to x at x equals 5 is 2 over 5 squared plus 30 over 5 cubed, which is 2 over 25 plus 30 over 125. Now if we simplify the second fraction to make sure we've got common denominator of 25, we have 2 over 25 plus 6 over 25, giving us a gradient of the tangent to the curve of 8 over 25.